Hello children, welcome to the next part of this video. As we know that our topic was area related to circles. We have learned so far how to find out the area of a quadrant, area of a sector, length of an arc. So let us recall the formulas that we have learned in earlier videos. First one is area of sector is equal to theta divided by 360 into pi r square is the area of a sector. And second one is length of arc is equal to theta divided by 360 into 2 pi r. Into 2 pi r, this is the area of a sector, theta divided by 360 into pi r square. We know that theta is the sector angle and r is the radius of a circle, and length of arc is theta divided by 360 into 2 pi r. 2 pi r is the circumference of a circle, and here pi r square is the area of a circle. On the basis of these two results, we have done exercise 12.1 and some questions of 12.2. Let us start from question number 7 of exercise 12.2. The question is, a chord of a circle of radius 12 centimeters subtend an angle of 120 degree at the center. Find the area of the corresponding segment of a circle. But in this question, we have to use the value of pi. It is 3.14 and square root 3 equals to 1.73. Exercise 12.2, question number 7. Question number 7 is, a chord of a circle of radius 12 centimeter. Let us draw the circle of this diagram of this question. This one is a circle. Let this point be the center of this circle and call it as O. And it is given that the radius of this circle is 12 centimeter. This is 12 centimeter. So OA is the radius. Let us take another radius, that is OB. It is also 12 centimeter. A chord of a circle of radius 12 centimeter subtends an angle of 120 degree at the center. That means this sector angle given, it is 120 degrees is the measure of this one. Then find the area of the corresponding segment of the circle. So let us join this A to B, this AB. The corresponding segment is here, this one. This shaded region is the corresponding segment. Let this point be here C. So A, C, B is the corresponding segment of this circle. Now we have to find out the area of this segment. Clearly, if we take A, OACB as a quadrant and OAB is a triangle, so area of a quadrant minus area of a triangle will be equals to the area of this segment A, C and B. So for this question number 7, radius R equals to 12 centimeter. Theta is equal to 120 degrees. Then we have to find out this area of segment ACB. So area of ACB is here segment is equal to area of OACB. What is OACB? It is the sector of the circle minus area of a triangle, that is OAB. So area of ACB is equal to area of the sector. We know that area of a sector is theta divided by 360 into pi r square. It is theta, the theta is here 120 divided by 360 into pi, the value of pi is here 3.14 into r square, r is here 12, r square means 12 into 12 minus area of a triangle, that is r square. You can write first of all r square sine theta by 2 cos theta by 2. It implies 120, 0 and 0 cancel, 12 1R, 12 3R, and 3 1R 3, 4R 12. It becomes here 3.14 into 12 into 4 minus R square is clearly 12 into 12 sine theta by 2. The value of theta is here 120. Theta by 2 means 120 divided by 2, that equals to 60. So sine 60 is equal to square root of 3 by 2 into cos 60 is 1 upon 2. Here it is 3.14 into 12 into 12 is, 12 into 4 is 48 minus 144R. This is 2 1R 2, 2 6R 12, 2 1R 2, 2 3R 6. It becomes 3 into 12 is 36 into square root 2. The value of square root 2, it is given in the question, use square root 3 is equal to 1.73. It is 1.73. After calculating or multiplying 3.14 into 48, we get the result is 150.72. It is here 150.72 minus, when you multiple 36 into 1.73, you get 62.28. This is 62.28. So after subtracting the 2, we get the value 150 minus 72 minus 62 point this 28. The result is here 88.44 square centimeter is the area of this corresponding segment. So once again we recap this question. So we have a sector OACB here, and the radius is given, that is 12 centimeter each, and the sector angle is given, that is 120 degrees, and we have to find out the area of this corresponding segment, that is ACB. Clearly this corresponding segment, we can find this area by area of OACB, complete this sector, minus area of this triangle OAB. The formula for finding the area of this OAB triangle is R square sine theta by 2 cos theta by 2. After putting the values of thetas here, we get it is theta is 120 divided by 2, that is 60. So sine 60 is square root 3 by 2 into cos 60 is 1 upon 2. And after calculating the values, we get the answer here. Area of this ACB sector is equal to 88.44 centimeter square. Now after question number 7, completing the question number 7, we take question number 9. A brooch is made with a silver wire. A brooch is made with a silver wire in the form of a circle whose diameter is 35 mm. And the wire is also used in making 5 diameters, which divides the circle into 10 equal parts. As shown in this figure, we draw the figure of this question. So here is question number 9. Question number 9 states that we have a silver wire. We have a silver wire whose which is used to make a circular brooch whose diameter is 35 mm, and the wire is also used in making 5 diameters. First of all, we draw the diagram of this question. So let us draw a circular brooch here like this, and also draw the 5 diameters of the circle. Let this one be the 1, 2, 3, 4, and 5. This one be the center point here, and we call it as O. The wire is used in making the circular brooch with 5 diameters, and the diameter of the each length of the diameter is equal to 35 mm. So first part is, what is the length, the total length of the wire required, and the area of each sector of the brooch. So first one is the radius, question number 9, diameter equals to 35 mm. millimeter. Therefore, radius is equal to 35 divided by 2 millimeter. Then, first one is length of the wire used. Length of wire is equal to, clearly the wire is used in making the circular bruise and 5 diameters. It is the length of a wire is circumference plus length of 5 diameters. Length of 5 diameters. So the circumference of a circular bruise is, it is 2 pi r plus 5 into diameter. What is the length of a diameter? It is given 35 mm. So here it is 2 into 22 by 7 value of pi into r radius that is given, it is 35 divided by 2 mm. 35 by 2 plus, after multiplying it, you get 5, 5, 25, 5, 3, 15, plus 1 is 175 mm. Here we can cancel this 2 and 2, and this 7, 1, 7, 5. Here it is 22 into 5 is 110 millimeter. 285 millimeter is the total length of the wire which we use in making this circular bruise along with the 5 diameters. Now the second part of the question is the area of each sector of the bruise. That one is each sector. This sector, so this bruise is divided into 10 equal sectors by these 5 diameters. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the sector angle, first of all, this sector angle can be found by, we know that this angle, complete angle is equal to 360. It is divided into 10 equal parts. Therefore, the angle of sector or sector angle is equal to complete angle 360 divided by the number of equal parts, that is 10 here. So second part is, part second is theta is equal to total angle, complete angle 360 degrees divided by the number of equal parts, that is 10. That equals to 36 degrees is the value of theta here. Now area of each sector is equal to theta divided by 360 into pi r square. That means it is theta is 36 divided by 360 into pi is 22 by 7 into r square. R square is clearly here 35 divided by 2 whole square. That equals to 1 divided by 10. After cancellation, it get 22 by 7 into 35 by 2. It is square, so we can write it as 35 by 2 into 35 by 2. So here it is 7 1 r 7, 7 5 r 35. Then 2 1 r 2, 2 11 r 22. Then again 5 1 r 5, 5 2 r 10. We get here it is 11 into 35. 11 into 35 divided by, that is 2 and 2 is here, that equals to 4. It becomes here 35 into 1 is 35, 35 into 1 is 35 plus 1 is 36. 365 divided by 4 millimeter square is the area of each sector of this bruise. So which is divided into 10 equal parts. Then we can find in second part, first of all sector angle, that is 360 divided by equal parts 10, that equals to 36 degree is the angle here, theta. So area of each sector is the theta divided by 360 into pi r square. After calculating, we get the area of each sector of this bruise. Now question number 13 is here. A round table cover has 6 equal designs. A round table cover has 6 equal designs as shown in the figure. Then if the radius of a cover is 28 centimeter and find the cost of making the design at the rate of 0.35 per square centimeter, and here we use square root 3 equals to 1.73. Question number 13. 13 is we have a round table cover have 6 equal designs as shown in the figure like this. This one is a round table cover has 6 equal designs. If we draw the 6 equal designs here, it is a 3, 4, 5, 6 are the 6 equal designs here. So the design is here this way. These are the 6 equal designs. We have to find out the area of this design. There, if we join the lines here, this one, this. So this center angle is divided into 6 equal parts. 1, 2, 3, 4, 5 and 6. We have to find out the design here. So if we have, it is given that the radius is equal to 28 centimeter. This is 28 centimeter. Here first of all we can find this sector angle. In question 13 we have radius R is equal to 28 centimeter. It is given in the question. Then sector angle theta is equal to 360 divided by the equal parts. That equals to 6. That implies it is 60 degrees. That means the center angle here is 60 degrees. This is 60 degrees. Now, we call this point as O, this is A and this is B. So, what is OAB? Now, it is two sides are equal, it is isosceles and one angle is equal to 60 degrees. So, therefore, OACB is an equilateral triangle. Now, we can find out the area of a design clearly. The area of a design can be found by area of a circle, complete circle, minus area of 6 equilateral triangles. Minus area of 6 equilateral triangles. In this equilateral triangle, we have side given, we have angle given, and for this area of a design is area of design is equal. Clearly, area of the complete circle, area of circle minus area of 6 equilateral triangles. Area of 6 equilateral triangles. So, area of the circle is, we know that it is pi r square minus area of 6 equilateral triangles. It is 6 into area of an equilateral triangle. We know that it is square root 3 divided by 4 into side square. So, what is the area of a circle? It is pi r square. We can pi use here 22 divided by 7 is the value of a pi here. It is 22 divided by 7. R is 28 into 28 because it is r square minus 6 into the value of square root 3 in question it is given is equal to 1.7. It is 1.7 divided by 4 into side square. Side of an equilateral triangle is clearly 28. It is 28 square. Here we can cancel out 7 1 or 7, 7 4 or 28. It becomes here 4 into 22 is 88 into 28 minus it is 2 2 or 4, then 2 3 or 6. We can write here it is 3 into 1.7 into 28 into 28. divided by 2. So here it is 88 into 28 minus, we can cancel here, 2 1 r 2 14 r. So it becomes here 3 into 7 is it is 5.1. After multiplying 3 into 1.7 into 28 into 14. After calculating the values here, 88 into 44, we get the value 262464 minus 1999.2 square centimeter. When you subtract the two, you get the result here 464.8 square centimeter is the area of a design. Is the area of, so the area of a design is 464.8 square centimeter. Now in the question, second part of the question is, what is the cost of the design? If the cost of 1 square centimeter is rupees 0.35, so we multiple 464.8 with 0.35, we get the cost of this whole design. Now cost of a design is, cost of design is equal to 464.8 is the area of the total design into cost of 1 meter square is 0.35. After multiplying the two, you get the total cost is 162.68 rupees is the total cost of this design. Now we have another topic here, combinations, area related to combinations of so many figures. So here we have an exercise number 12.3. Question number 1 is for exercise 12.3. The statement of the question is, find the area of the shaded region. Now we have the combination of figures. Problem is based on combination of figures. So find the area of a shaded region. If the length of a PQ side is 24 centimeter and PR side is 7 centimeter and O is the center of a circle. First of all, we draw the diagram of this question. It is exercise, next exercise 12.3, question number 1. These examples or these questions are based on combinations of figures. Exercise 12.3. Question number 1 is, find the area of the shaded region given in the figure. Draw a figure. This one. It is given that this one is a line which passes through the center. Clearly, this point or this line segment is known as the diameter of the circle. It is given in question, it is RQ, is the diameter of the circle. And here is another point, P. This point is P. This is QR. So QP, RQ and RP is a triangle here. RPQ is here a triangle. So it is given PQ equals to 24 centimeter. PQ is this one, is 24 centimeter. PR or RP is equal to 7 centimeter. We have to find out the area of the shaded region. This one is the shaded region here. This part. This is the shaded region. We have to find out this area. So first of all, this shaded region lies in the semicircle RPQ. So for this triangle or this semicircle, we have a triangle RPQ. We know that in class 9th, we have studied that angle in a semicircle is equal to 90 degrees. So RQ is the diameter and this diameter subtend angle RPQ. Here, that means this angle is 90 degrees angle. So, in triangle RPQ, angle RPQ is equal to 90 degrees. Why? Reason is angle in a semicircle. Angle in a semicircle. So if this angle is equal to 90 degree, clearly this RPQ is a right angle triangle. When we have a right angle triangle and two sides of a right angle triangle are given, so we use Pythagoras theorem to find out the other side of the triangle. So in this triangle, by Pythagoras theorem, by PGT, what is hypotenuse here? It is RQ square is equal to base square is 7 square plus altitude is 24 square. RQ square is equal to 49 7 square plus 576 is 24 square. You get RQ square is equal to here, when you add you get 625 is RQ. But 65 to 625 is the square of 25. We can write RQ is equal to 25 centimeter. So this one is 25 centimeter. Clearly, RQ is the hypotenuse of the triangle as well as the diameter of the circle. Therefore, radius is equal to 25 divided by 2 centimeter is the radius of this semicircle or this circle. Now, we have to find out the area of the shaded region. Clearly, the shaded region is in the semicircle. So, we can find out the area of a shaded region by area of a semicircle minus area of this right angle triangle. So, we know that area of a semicircle is pi r square divided by 2 and area of a right angle triangle is 1/2 of base into altitude. So, here area of shaded region is, so area of shaded portion is equal to area of semicircle minus area of triangle RPQ. So, area of a semicircle is pi r square divided by 2 minus area of a triangle is 1/2 of base into altitude. The base is here 7 and it is 24. Now, the value of pi is here 22 divided by 7 into r square. R square is here, radius is 25 is the diameter and radius is 25 divided by 2, 25 divided by 2, this is pi r square and this one is 1/2 this one. So, pi 1 divided by 2 is here, pi is 22 by 7 into r square is 25 by 2 into 25 divided by 2 minus, we can cancel here 2 1 r, 2 12 r. That means 7 into 12 is 7 to 14, it is 84. 7 into 12 is 84. So, after calculating, we get 1 divided by 2 into. So, here it is 2 1 r to 11 r. We get 11 into 25 into 25 divided by 14 minus 84. So, here it is 1 divided by 2 into 11 into 625 divided by 14 minus 84. Here 1 divided by 11 into 625 divided by 14, it is 2 into 14 is 28 minus 84. After calculating the values, you get the result here. Area of the shaded region is equal to, after calculating 11 into 625, so we get it is 4523 divided by 28 square centimeter is the area of this shaded region. Clearly, in this figure, we have a combination of figures. We have a circle and a triangle. In this triangle, this triangle lies in the semicircle. So this angle is equal to 90 degrees. Because angle in a semicircle is equal to 90 degrees. So this angle is 90. If we have a right angle triangle, we can use Pythagoras theorem to find out it is hypotenuse, that is RQ. It is hypotenuse as well as the diameter of this semicircle. After finding the diameter, we can use this formula for the radius is 25 divided by 2, and the area of the shaded region is area of a semicircle minus area of a triangle. After calculating, we get the area of the shaded region is equal to 4523 divided by 28 square centimeter is the area of the shaded region. Let us take another example of the same exercise 12.3. The example is example number 4. Find the area of a shaded region in which where a circular arc of a radius 6 centimeter has been drawn with the vertex O of an equilateral triangle OAB upside 12 centimeter as center. So first of all, we draw the diagram of the question. Is this one is an equilateral triangle. We know that a triangle is said to be an equilateral triangle when all the three sides are equal and all angles are 60 degrees each. And the figure is like this. We have to find out the area of a shaded region. So this point be the center of the circle and the vertex of an equilateral triangle. And this is A here, this is B. It is given in the question, the side of an equilateral triangle OAB is equal to 12 centimeter. This is 12 centimeter. This one is also OB 12 centimeter and OA is 12 centimeter. Now, this one is here point C and this one be point C and D here. In this, we have OC is the radius of the circle. It is given that equals to 6 centimeter is the radius, and this OD is also the radius equals to 6 centimeter. And OAB is an equilateral triangle, and this angle is the sector angle, also the angle of an equilateral triangle, and it is equal to 60 degrees. Now, what we have to find? We have to find out the area of the shaded region. Which region is here shaded? This whole part is the shaded region here, this one. So, we have to find out the area of a shaded region. So, first of all, we find the area of an equilateral triangle OAB and the area of this major sector. This one is the major sector, this sector. But for finding the area of a major sector, we should have to find the area angle of a major sector. This one is the angle of major sector. This one is the angle of major sector. Clearly, this angle is equal to 60 degrees and this one is the major sector, this angle. So it is equal to 360 minus this 60 degrees angle. That means this one is the major angle or major sector angle, that equals to 300 degrees. So how to find out the area of a shaded region? Area of an equilateral triangle OAB plus area of a major sector. So the angle of major sector is here 360 degrees minus 60 degrees. So question number 4, theta is equal to area of angle of minor sector is equal to 60 degrees. Radius is equal to 6 centimeter. Side of equilateral triangle is equal to 12 centimeter. Now, angle of major sector. Let it be theta is equal to complete angle. This is 360 degrees minus 60 degree, that equals to 300 degrees is the angle of major sector. Now we have to find out area of shaded region. That is equal to area of equilateral triangle OAB plus area of major sector. Area of major sector. That equals to area of an equilateral triangle. We know that it is square root of 3 by 4 into side square. But here side of an equilateral triangle is 12 centimeter. It is 12 square plus area of the major sector. We know that area of a sector is theta divided by 360 into pi r square. So area of a major sector is here theta. This theta is the angle of major sector, that equals to 300 divided by 360 into pi r square. Pi is here 3.14 into r square is here 12 into, sorry, it is 6 into 6 or 6 square. So it is square root of 3 by 4 into 12 square is 144 plus, we cancel out here 0 and 0 cancel, it equals to 5 into 6 into 5 for 30 and 6 into 6 is 36 into 3.14 into 36, because 6 square is here 36. So we cancel here 6 1 r 6 6 r. It is it implies square root of 3 by 4 into 144 plus 5 into 3.14 into 6. So after calculating, we get the value here. It implies area of the shaded region is equal to square root 3 by 4 into 144. We get the result here. That implies area of an equilateral triangle after calculating square root 3 by 4 into 144. We get it is 61.2 centimeter square plus area of 5 into 3.14 into 6, that equals to, after calculating, you get 94.2 square centimeter. So the area of the design is equal to, this is 4.4 plus 1 is 5 and 9 plus 6 is 15. It implies 155.4 square centimeter is the area of the shaded region. So here we have a circle whose radius is equal to 6 centimeter and the equilateral triangle OAB whose side equals to 12 centimeter each. We have to find out the area of the shaded region. So we, first of all, the angle of the minor sector is here 60 degrees. Then the radius of the sector, that is OCD, is a sector, radius is equal to 6 centimeter and the side of an equilateral triangle is equal to 12 centimeter. So here angle of a major sector is equal to, that is 360, means complete angle minus this 60 degree angle, that equals to 300 degrees. So the major angle of a sector is equal to 300 degrees. Now area of the shaded region can be calculated by area of an equilateral triangle OAB plus area of the major sector. So the area of a major sector is theta divided by 360 into pi r square. After calculating, we get the value, that is 155.4 square centimeter is the area of the shaded region. Now the next example of the same exercise is example number 10. That is The area of an equilateral triangle ABC is given 173 to 0.5 square centimeter. With each vertex of a triangle as center, a circle is drawn with a radius equal to the half of the length of the side of an equilateral triangle as shown in the figure. Find the area of the shaded region. In this question we have used pi equals to 3.14 and square root 3 equals to 1.73205. So the figure is like this. We have an equilateral triangle again. This one. We have to find out the area of this shaded region, this region. So this triangle is A, B, and C. It is given in the question that the vertices of the equilateral triangle are the centers of the three circles A, B, and C. And the radius of each circle is equal to the half of the side of an equilateral triangle. But here the area of an equilateral triangle is given. So area of a triangle ABC is equal. It is given. It is 17320.5 centimeter square is the area of an equilateral triangle. But we know that area of an equilateral triangle is equal to square root of 3 by 4 into side square is equal to 17320.5 divided by 10. After this vanishing this decimal point 5, we can divide it by 10. It is square centimeter. Now, it is square root 3. In the question it is given that u square root 3 is equal to 1.73205. It is 1.73205 then divided by 4 into side square is equivalent to 17320.5 divided by 10. Now, we have to find out here the side of an equilateral triangle. Side, we have multiplication 1.73205 divided by 4. Or we can write it as, it is 17320.5 divided by 4 into 1 and 1, 2, 3, 4 and 5 zeros into side square is equal to 17320.5 divided by 10. So we have to here find the side of an equilateral triangle. We can write side square is equivalent to 17320.5 divided by 10 into. When we transpose this thing to the right hand side, it will reciprocal here. It is 4 into 1, 2, 3, 4, 5 divided by 17320.5. Clearly, this 17320.5 cancel with this 17320.5. And this 0 and this 0 cancel. It is 10,000 into 4. 4 into 10,000 is equal to 40,000. That implies side square is equal to 40,000 centimeter. It is side square is equal to 40,000 centimeter. Now, what is side? Side is equal to, clearly 40,000 is the perfect square of 200. So, side equals to 200 centimeter. So, the side of an equilateral triangle is here 200 centimeter. Now, according to the question, the radius of each sector is equal to the half of the side of an equilateral triangle. Now, what is the radius of an equilateral this each sector? It equals to half of 200. That equals to clearly 300 centimeter. Therefore, radius is equal to half of 200. That equals to 100 centimeter is the radius. Now, what we have to find here? Area of the shaded region. Clearly, area of a shaded region lies in between this equilateral triangle ABCD, and we have here three sectors. This sector, this, and this one. So, for finding the area of the shaded region, we can take the area of a whole equilateral triangle ABC minus 3 times the area of a sector. So, we know that what is the area of a sector? Theta divided by 360 into pi r square. So, for finding the area of sector, we can use the formula as now area of shaded region is equal to area of equilateral triangle ABC minus 3 times the area of a sector. 3 times area of sector. That implies area of an equilateral triangle is given, that equals to 17320.5 minus area of 3 sectors, that is equal to 3 into area of a sector is theta, that equals to 60. Why 60? Because it is an equilateral triangle. Each angle is equal to 60 degrees. So it is 60 divided by 360 into pi. In the question it is given that use pi equals to 3.14 into r square. What is the radius here? So radius is 100 centimeter. R square is 100 into 100. That implies it is 17320.5 minus, we cancel out here 0 and 0 cancel, 6 1 r, 6 r 36, then 3 1, 3 2, then 2 1 and 250 r. So here we have, it is minus here, 3.14 into 100 is 314 into 50. That implies it is 17320.5 minus 314 into 50. When you multiply it, you get minus 157 and 2 times 0. When you multiply 314 into 50, you get 15700. Then after taking the subtraction 17320 minus 0.5 minus 15700, we get here 1620.5 square centimeter is the area of the shaded region. So for this question, we have an equilateral triangle whose area is given, and the 3 vertices of an equilateral triangle are the centers of 3 circles, and the radius of each sector is equal to half of the side of an equilateral triangle. First of all, we have here finding the area side of an equilateral triangle, then the radius of an each sector, then find the area of a shaded region. Area of a whole triangle minus ABC minus 3 times the area of a sector. We get here 1620.5 square centimeter is the area of this shaded region. Now the next example is here, example number 13 of the same exercise. Now example number 13 is in a figure a square OABC is inscribed in a quadrant OPBQ. If OA equals to 20 centimeter, find the area of the shaded region. Use pi equals to 3.14. So the figure of the question number 13 is, this is question number 13. We have a quadrant here, like this. This is the figure of question number 13. It is a quadrant. If it is quadrant, then this angle is equal to 90 degrees. And a square OABC this is O, this is O, A, B, C is a square. If it is a square, means all sides of a square are equal. So in the question it is given that the side is OA, it is 20 centimeter. This is BA or AB, it is also equal to 20 centimeter. This BC is also 20 and this OC is also 20 centimeter, because all sides of a square are equal and each angle is equal to 90 degrees. Then what we have to find here, area of the shaded region. This one is the shaded part here. This one. We have to find out this area of the shaded region. This is O, A, P, and this one is Q here. So we have here two figures. One is O, P, B, Q. That is a quadrant, and another one is O, A, B, C. Is a square. So the area of a shaded region can be found area of the quadrant OPBQ minus area of the square OABC. But the area of a quadrant is theta divided by 360 into pi r square. Theta is clearly here 90, but the radius of the quadrant is not given here. How to find out the radius? Clearly we can join this one, O to B, this OB. OB is the radius of this quadrant. The definition of the radius is a line segment whose one end point on the center and other on the circumference of a circle. That means OB is the radius of a circle as well as the diagonal of a square OABC. And we know that diagonal of a square divides the square into two right triangles. So here we have a right triangle OAB. In this right triangle, we have two sides given. That is OA 20 centimeter and AB 20 centimeter. In a right angle triangle, when two sides are given, then we use Pythagoras theorem to find out the third length of the third side. That third side is here, OB. This is the radius as well as the diagonal of the square OABC. So question number 13 is, we have to join OB. Now in right triangle O, A, B, by Pythagoras theorem, by PGT, hypotenuse square is here OB square is equal to base square is 20 square, means OA square, plus altitude square is AB square, it is also 20 square. So OB square is equal to 420 square plus 400. It implies OB square is equal to 400 plus 400 can be written as 2 times 400. That implies what is OB here? OB is equal to square root of 2 into 400. So here 400 is a perfect square of 20. We can write OB is equal to 20 square root 2 centimeter is the hypotenuse as well as the radius of the circle. Therefore, radius R is equal to 20 square root 2 centimeter is the radius of this quadrant. Now, we have to find out here this area of a shaded region. Now, area of a shaded region can be found as area of OPBQ, means area of the whole quadrant minus area of this square. So, area of shaded region here, area of shaded region, area of a shaded portion is equal, it equals to area of OPBQ. What is OPBQ? Clearly it is a quadrant because one angle equals to 90 degree minus area of OABC. What is OABC here? It is a square. So it implies area of a quadrant OPBQ is equal to theta divided by 360. What is theta here? 90 divided by 360 into pi. Here we have to use pi, 3.14 into r square. What is r here? R is 20 square root 2 and r square is 20 square root 2 square minus area of a square that equals side square. What is side of a square? It is 20. We can write it as 20 square. So we cancel out here. It implies 90, 0, 0 cancel, 91 r, 94 r. We get, it is 1 divided by 4, 3.14 into 20 square root 2 whole square. Now area of shaded region is equal. It is 1 by 4 into 3.14 into 20 square root 2 whole square, that equals to 400 into 2. This 20 square is 400, square root 2 square is 2, minus 400. Now here it is 1 by 4 into 3.14. We can write it as here 100 into 4 into 2, because 400 is equal to 100 into 4. Why we use it? Because 3.14 into 100 can be calculated as, it is 1.1 by 4 into 314. When you multiply it with 100 into 8, 4 into 2 is 8, minus 400. Clearly 4 1 r, 4 2 r, 8 here. It implies we can multiply 314 into this. It is 8, it is 2, it is 6, 28 minus 400. That implies when we calculate the value of 628 minus this, we get 228 centimeter square is the area of the shaded region. That is, we have 628 minus 400, we get 228 centimeter square is the area of this shaded region. Again, in this question, we have a quadrant given, OPBC. In quadrant, this angle equals to 90 degrees, and we have a square, OABC, in which the side of a square is given 20 centimeter. We have to find out the area of this shaded region. First of all, we can find the radius of this circle by joining the diagonal O and B. Here we join OB, we get a right angle triangle OAB using Pythagoras theorem for finding this OB, that is the hypotenuse, as well as the radius of this semicircle. It was 20 square root 2 centimeter. Then after finding the radius, we can find the area of the shaded portion, that is area of OPBQ minus area of a square OABC. The formula is theta divided by 360 into pi r square minus area of a square is equal to side square. Side is given here 20. So we get, after calculating, the area of the shaded region is 228 square centimeter.